All right, so we are trying to find that. How far does it travel horizontally? What do we know?
It's going 50 meters per second.
Is that I hat or J hat, or some combination? Yeah, so initial velocity is in the I hat direction, that's 50 meters per second. What is the J hat component?
Just 600 meters.
Okay, what else do we know?
0.
I thought that's what you said.
I said 20, but
Oh,
that makes sense as initial.
yeah, the 20 comes in, what is the 20?
The final.
Not the final, not a final velocity. If that's where you're at. Think about the units of the 20.
I mean, it's distance, like distance. Are you asking me like which one of those it will fit in?
Yeah. 20 shows up somewhere.
Should be your J displacement.
Yeah. That's how far, from here to here, it goes down 20 meters, and since we said down was positive J hat, positive 20. That's my final, that's my displacement. The reason I sort of hesitated on when you said it was the final, if you consider this to be position is equal to 0, then our final position is 20 meters.
That's what I thought you were.
Okay.
The final velocity for I hat is going to be 50, with absence their resistance.
Yes. There's a video where I actually do take air resistance into account for projectile motion, assuming that air resistance is proportional to the speed. It's worth a look, and potentially will help you understand why we ignore it this time. Why is the final velocity horizontally 50?
There's no reason it would slow down.
Or speed up?
Yeah.
Ultimately, because the acceleration is 0 horizontally.
Oh.
What about vertically?
9.8 meters per second squared.
All right. So I know 3 things here on the right side. I know only 2 things on the left side. We do have one thing in common to both of them. It is time. Time is the glue that gets them together. The ball will be in the air horizontally just as long as it's in the air vertically. So we're going to use the vertical stuff to find time, and then we're going to, once we have time, we'll be able to solve for this. So what equation should we use? To find time. It's one of the cake formulas that was up here, but it is not anymore.
We would use the first formula.
We don't know VF or time. For the first one I had written up here.
The third one,
But we do know.
the delta x equals initial velocity times time plus 1/2 acceleration times time squared.
That's going to get us to it in one equation. If you want to find final velocity first, using the VF squared minus VI squared equals VF squared equals VI squared plus 2A dot delta x. You could find VF that way and then plug into the first one to find time, or in one shot this way. In this particular case, since VI is 0, this is probably, in my opinion, the simplest. You just plug in, so that's 20 is equal to 0 times time plus 1/2 9.8 times squared, or 20 equals 4.9 times squared. And time is 2.46. No, a little bit more. 2.56. The real answer is
2.02.
2.02. Oh, yeah, okay, sorry. I did 20 divided by 4, not 5. 2.02 units.
Seconds.
All right. So we now have this 2.02 seconds, 2.02 seconds. And we now solve for this. Which equation do we use to solve for that?
Our second one. Or, no. Same equation?
Same.
Yeah, same equation. Different color. So plugging in now, R is equal to 50 times 2.02 plus 1/2, 0 times 2.02 squared. That obviously goes away, and we're left with 100.1. I think. Is that
100, I thought it would be 104.
I got 101.
101? Okay. So what you're saying is I'm wrong. That's what I'm hearing.
Yes.
Okay. I'll buy that. So we know how far it's going out horizontally. It's going 101 meters out where it's going to hit. So in this problem that we had here, when I had the balls being shot horizontally, if we know how far out it goes, we can, and we know the height, we can predict how fast that ball was going when it got projected out. All right, so let's find out in the little bit of time remaining, what is the velocity right before it touches the ground? Because once it touches the ground, we now have an additional force involved. The acceleration is no longer constant. So it's, even though the language typically in physics is, what's the velocity when it hits the ground? What is meant by that is just before it touches the ground.
Would our velocity in the I hat just be 9.8 multiplied by 2.02?
I hat?
J hat.
The other one, okay. Yeah, J hat would be, because you're basically plugging into VF equals VI plus AT. And so we have 0 plus 9.8 times 2.02, so what do you get?
19.796.
Meters per second, and horizontally?
Takes speed 50.
Yeah, the acceleration is 0, so it doesn't change at all. And so our final velocity in rectangular form, given this convention right here, is final velocity is 50 meters per second, I hat, plus 19.796 meters per second, J hat. What is the final speed? Well, we have two options here. We can plug into, well, not there anymore, the VF squared equals VI squared plus 2A dot delta X. Or, Pythagorean theorem. Because I'm saying the final velocity is 50 meters per second this way, plus 19.796 meters per second that way. And so my speed is the hypotenuse there.
Is it really that simple to find the vector speed? Or the?
Yeah, if you have it in rectangular form, yeah.
Alright, I'm getting 53.7762.
And the angle at which it hits? Which I will originally call theta.
Would that be tangent of 50 over 19 point?
You see the ballpark. You're saying some of the right words, the order's wrong though.
Right, opposite over adjacent.
Seems to be somewhere around 20 degrees.
Yeah. Hey, okay, 21.1. Oh, 025.
No, misinterpreted the look.
Oh, degrees.
Yeah, there we go. How'd you get 21.1?
Arctan 19 over 50.
Yeah. And no doubt, the trick brings back some more fond memories. Any questions? Then, have an enjoyable evening. Which we all know can only be enjoyed if you're doing physics.